everyone, welcome back to series where we are discussing network security theory part. So here we started discussing substitution technique, and in that substitution technique we are already done discussing one algorithm which is named as Ceasar Cipher. So in this particular algorithm, as you can see in this particular diagram, what we do, we basically replace original alphabet 3 position up the line with some another alphabet, or 3 position down the line with some another alphabet. So that is what we mean by substitution technique. As you can see, we can replace D with 3 position down the line alphabet, that is A. So if we count from D, we have on third position we have A on downside, first, second and third. This is how we basically substitute alphabets, or we basically encrypt our message using Ceasar Cipher. But there are many drawbacks, because anyone who basically aware of this particular algorithm, that person can easily crack our algorithm, or that person can easily decrypt our original message. So if we want to secure it, then we follow a bit advanced level of algorithm. So here we have one advanced level of algorithm that is known as modified Ceasar Cipher. So as you can see in modified Ceasar Cipher, it is not always compulsory that we are going to replace one alphabet always with another alphabet which is 3 position down the line or 3 position up the line, but instead we can replace one alphabet with any other alphabet which is present in our total number of alphabets which we have, that is 26 alphabets. So if I talk about A, I can replace this A with any alphabet, rest of any 25 alphabets. As you can see here, it is given in a diagram that we have a key, that is 19. That means we are going to replace each and every alphabet with 19th position alphabet which is present on 19th position from this particular alphabet, or at any particular level. You can just imagine with the help of this particular diagram that we have two circles like this. One is outer circle, that is our original message, and inner circle, that is our encrypted message. So what we need to do, we just need to rotate this particular circle. So as you can see, front of A we have T. So now what we are going to do, we are going to replace A with T, B with U, C with V, D with W, like this. So I hope this is the best possible way we can remember this particular algorithm. Let's just discuss theory part of the same. The Ceasar Cipher is good in theory but not good in practice. Why? Because it is very simple. Any person who basically know very well, or who basically aware of this particular algorithm, that any person can break our original message. So what we need to do, we are going to use a modified version of this particular algorithm, or we can say an advanced or some different, a bit different. We are going to make some changes. So let's assume that the Ceasar text or alphabet corresponding to original plain text alphabets may not be necessarily be 3 placed down the order, but instead it can be any place down the order. That's what I just explained you now. Thus it is very difficult for any hacker or any attacker to decrypt our message so easily, but still that person can decrypt our message. Why? Because he just want to make 25 attempt. As we know, we have total 26 alphabets in our we have 26 alphabets in total. So if I am replacing A with some another alphabet, remember I am not going to replace A with A only, because that's useless. It is like doing nothing for encryption. So what we are going to do, we are going to replace A with rest of 25 alphabets which is present. So if any person wants to decrypt our message, or if any person wants to crack our algorithm, that person is going to try maximum 25 attempts only, and within those 25 attempts one can 100% decrypt our message. So in this particular algorithm as well, we have many drawbacks. It is not so secure that we can use it at financial level transaction, or at some current era where we are using WhatsApp or Gmail or some other services. In current trend, this type of algorithm are totally useless. But we need to understand basics of this particular algorithm, because advanced algorithms are based on this particular algorithm only. So if we are not aware about this basic algorithms, then it gets very difficult to understand other algorithms. So that's why we need to discuss this particular algorithm. So as you can see that we are going to replace one alphabet with any alphabet, rest of any 25 alphabets. Thus we are not saying that an alphabet in plain text would be necessarily be replaced by D, that is 3 position up the line or 3 position down the line. It can be replaced by any valid alphabet, that is by order E, F, G and so on till Z. Once the replacement scheme is decided, it would be constant and will be used for all other alphabets. That means I just need to find out one key and rest all other alphabets are encrypted in the same manner. So I just need to find that particular key, whether I have replaced each alphabet 10 position down the line, 8 position down the line or 7 position down the line. So that is my key. So once I find, once I basically come across your technique, I can replace all other alphabets with the same number or with the same technique. So here, as you can see, of course, it does not make sense to replace an alphabet by itself, that is replacing A with A. Thus, for each alphabet, we have 25 possibility of replacement. Hence, to break a message in the modified version of Ceasar Cipher, our earlier algorithm would not work. And here, if someone wants to break this particular message, then maximum 25 tries they need. And within those 25 tries, one try is going to be a successful try. Now, so as we know, this is also not so successful or not so secure algorithm. So for that reason, we are going to start with some another algorithm. So one is Ceasar Cipher, second is modified Ceasar Cipher. Now again, advanced level of this two algorithm, that is Monoalphabetic Cipher. So as you can see, this is a bit different from previous two algorithm. What is the difference here in Monoalphabetic Ceasar Cipher? So as you can see here, we are not going to replace same alphabet with the same text. For example, as you can see here, we have replaced H with some another alphabet, E with some another alphabet, and we have two same alphabets here, that is L and again L. So if we replace 2L with the same alphabet, then it is very easy for attacker to crack our message. And hence what we are going to do, we are going to use one different key for each and every alphabet which is present in our message. So as you can see, we can replace A with multiple alphabets. Same way we can replace B with also multiple alphabets. So once in my message, I'm going to replace B with E. Next time, if again B occurs in our message, then that time I'm going to replace B with Z. So one cannot easily find the pattern in our message. That is the only way. So as you can see, this is more or much secure compared to previous two algorithms. So here we basically use multiple alphabets to replace one single alphabet, that is E. We can be replaced with this 3 alphabets. So each and every time we are not going to replace same alphabet with another same alphabet. I hope this particular point is clear. This is what our algorithm, that is Monoalphabetic Cipher. We need to remember this particular definition for the same. As you can see, Monoalphabetic Cipher pose a difficult problem for cryptanalysts because it can be very difficult to crack thanks to high number of possible permutation and combination. So we basically use permutation combination mathematical technique here while encrypting as well as decrypting our message. The major weakness of previous two algorithm was its predictability. Why one can predict it? Because if I'm encrypting hello, and as you can see, if we talk about cipher or modified Ceasar Cipher, so there we basically replace L with same alphabet only. So one can easily guess that okay, here we have replaced one alphabet or there are multiple alphabets which are occurring. So anyone can guess the spelling or anyone can guess that particular word as well. That is, our word might be hello or word might be well, something like that, where we have multiple times same type of alphabets. But in this particular technique, it is very difficult. Why? Because we are not repeating the same alphabets or same logic more than once. That is the main technique or main pattern here. So let's just discuss. As you can see, once we decide to replace an alphabet in a plain text message with an alphabet that is k position up or down the order, remember we are just mentioning that particular number. That is, I can replace a with 8 position down the line, 7 position up the line, or any xyz way. So here what we are saying that the k position is not always fixed. K's value is not constant in our algorithm. So we replace all other alphabets in a plain text message with same technique. Thus the cryptanalyst has to try out maximum 25 possible attacks when we talk about previous. Now imagine that rather than using uniform scheme for all the alphabets in a given plain text message, we decide to use random substitution. That's what we discuss now. So this means that given plain text message, each A can be replaced by any other alphabet through B to Z. B can be replaced by any other alphabet from A or C through Z, and so on. A crucial difference is we know that if we are replacing B, and if B is occurring more than once in our message, then what we are going to do, once we are going to replace B with some another alphabet and again B with some another alphabet. As you can see, once we are going to replace B with E, then again we are going to replace B with Z. So it is very difficult for cryptanalysts to guess the technique behind this. To put it mathematically, we now have many permutation or combination of 26 alphabets. So what we mean by permutation or combination, we basically take out the factorial. What we mean by factorial, if I need to find out factorial of 3. So what is the factorial of 3? 3 into 2 into 1. The same way, what is the factorial of our total alphabets? That many possibilities now we have to replace each alphabet with another alphabet. So that is 26 multiplied with 25 multiplied with 24 multiplied with 23 goes up to 2. Those many possibilities, or you can say we have this much possibilities now, or this much type of patterns now present while encrypting our message, and those many types of attempts our attacker also need to try to decrypt our message. To this particular type is quite difficult for attacker to guess the pattern. I hope this particular algorithm is clear to each and every one of you. Now let's discuss the next algorithm. So as you can see here, the next algorithm what we are going to start is homophonic cipher. So what is homophonic cipher? Let's discuss one by one. In this cipher technique, plain text letter map to more than one ciphertext symbol. Usually highest frequency plain text symbols are given more equivalence than low frequency letters. So let's just discuss with this particular algorithm. So as you can see, we are going to use a message. As you can see, here is our message. He eats, then sleeps and dreams. So this is our message. Now what is our ciphertext? So for that we need to use following table is the key. So what is our table? As you can see, this is our table. Here we have multiple message. So for A we have one number. Then same way for B also we have some numbers present here. For C we have some numbers or some alphabets. So what we basically doing here, instead of replacing one alphabet with single another alphabet, what we are going to do, we are going to use alphabets, special characters as well as numbers for each and every alphabet. So A I can be replaced with, here I have table, so A would be replaced with a number that is 11, or I can replace A with this particular two alphabets that is AZ, or I can replace A with a special character that is @ or I can replace A with some another alphabet that is QA, or I can replace A with XF. The same way we can replace E with QP or 69 or double question marks, or with this particular number or this particular number or this particular number. I hope this particular technique is clear to each and everyone. So let's just discuss what is our message. So first plain text or first word is he, that is HE. So let's just check in our table. We have this many replacement for H. So H can be replaced with 55. So as you can see, we have replaced H with 55. Then E. So E can be replaced by many other alphabets. The same way we are replacing E with QP. As you can see, we have 55 and QP. This is our original message. I hope this particular technique is clear to each and every one of you. So in Ceasar Cipher, what we do, we replace original alphabet 3 position down the line with some another alphabet, or 3 position up the line with some another alphabet. In second, that is modified Ceasar Cipher, what we do, instead of 3 position down the line or up the line, we can replace A with any position down the line. That is, we have, except A, we have total 25 rest of position. So within that 25 we can replace A with any other alphabet. But there also, as we know, it is very weak, and anyone who basically aware of this particular algorithm, he can easily crack that particular algorithm, and hence that particular algorithm is not also secure. Then we discussed about monoalphabetic, where each alphabet can be replaced with any other alphabet or multiple alphabets. But there also, if we are replacing A, that is single alphabet, we replace with another single alphabet only. So it is very simple for anyone attacker or a cracker to guess that, okay, we have 5 words, so they need to identify pattern, or they need to identify word that contains 5 letters only. But here it is very difficult to crack anyone what is our original message. Why? Because if we have 4 alphabets in our message, or 5 alphabets, for suppose hello, then that message in an encrypted format is going to be much bigger than our original message. As you can see, if we talk about H, then H can be replaced with 2 alphabets. Then we have E, that can be replaced with 2 numbers or 2 alphabets, or 3-digit number as well. Same way L can be replaced with 2 alphabets, again with 2 alphabets. So it gets very, very difficult to guess, attacker or a cracker to at least guess how many alphabets or how many text or how many words basically present in our message. So this is the best possible algorithm we have. As we discussed all the algorithms till now, out of those 4 algorithms, this is the best algorithm we have. I hope this particular technique is clear. So let's just discuss the theory which is present here. So since more than 25 characters will be required in the ciphertext alphabet, various solutions employed to invent large alphabet such as numeric substitution, uppercase, lowercase, upside, and fanciful symbols. Fanciful symbols means dollar, @ then star, %, and hashtag, and many different things. So all we can do this. So as you can see, this is basically invented during a Roman Empire. That's what we are using in today's time as well. I hope this particular algorithm is clear. You can read this theory now. It is very simple. So you just need to remember this particular example. From this example, one can easily remember it. Next is Polygram Cipher. So what we mean by Polygram Cipher, as you can see here, instead of replacing one alphabet, remember, one alphabet at a time, we are going to replace the whole word at a time. So as you can see, what we are doing, we are encrypting one word at a time. So hello is basically substituted in this particular way. All previous 4 algorithms, they basically works in a character by character manner. From this algorithm, we are going to see how we can decrypt message or encrypt message in a word by word fashion. So this is what given here. So as you can see, let's just discuss the theory part here. The cipher technique replace one block. Remember here what this particular technique is called as block cipher, where we are going to basically encrypt one block at a time. So block, or we can say a plain text, a block of a plain text can be replaced with another block, and that is what we mean by block cipher or block of ciphertext. It does not work on character by character basis. Remember this particular point. Previous 4 algorithms, that is Ceasar Cipher, modified Ceasar Cipher, then we have polyalphabetic, and one more. I forgot the name. So basically all those 4 algorithms works on character by character basis. Now this Polygram Cipher works on block by block manner. So this crypto system makes crypto analysis harder by destroying the single character frequencies. So instead of replacing one character with another character, replace whole word with another word. Now remember, previous 4 algorithms are very slow as well, because if I want to encrypt whole document, then it gets very difficult. It is very slow. So if I want to decrypt, or sorry, if I want to encrypt whole textbook, then if I use algorithm which basically encrypt word by word or character by character basis, then if we have one reference book, then you can just imagine how much time it's going to take to encrypt that one textbook. Instead of that, what we need to do, we need to follow block by block pattern cipher algorithm, which is much faster as compared to character by character. So this is one of the difference, as you can see here. So for example, hello and hell could be replaced with any other alphabets. Cause, because could be replaced with some another text. I hope this particular technique is clear. So despite the character of 4 block of text being almost the same. Problem, what are the problems that we need to discuss now? So what are the problems present in polygram substitution? Different keys are required for each and every block of character. Remember, if we are using, if we need to encrypt 100 blocks, then we need to handle 100 different keys. One key for each block. So it is so much hectic work. It is very difficult to handle this many keys. And if we misplace, or if we miss 2 or few of the keys in between our message, then it is very difficult to again decrypt our message. So the encryption and decryption technique is applied to each and every block of character of text differently. Even the block is repeated in the plain text, so it requires more time to encryption. So this is slower as well. Character by character is also slower. So what is our requirement? We need secure and much faster algorithm. So that's what we need in now times. So we have some algorithm, that is polyalphabetic cipher. So let's discuss what we mean by this. So as you can see in polyalphabetic, actually it is a bit a big algorithm. We'll discuss in next lecture. Stay tuned. We'll continue next lecture discussing about polyalphabetic cipher. Thank you. Bye bye. And one more thing before I sign out. If you have any doubt or query, your queries are always welcome. You can write your question in a comment section. Plus one more thing, if you need these notes, I have already provided download link in video description section. So from there you can download these notes. Thank you. Goodbye. Have a nice day.